All right, welcome back for 5-2 part 2 notes. We're going to jump right in. We're going to add, subtract, and a little bit of multiplying and dividing as well. In order to add or subtract, we have to have like radicals. That means that the radicands are the same. At first glance, when we look at example 4a here, we think that hey, there's no like radicals, so we're all done. But we do have to simplify first to determine if there are like radicals. So we're going to open up Desmos and we're going to simplify all the radicals we can. Since 2 is such a small number, I know that that one is already simplified, so I don't have to worry about that one. But I am going to do the cube root of 2000 and the cube root of 128. So for graphing, I am going to take 2000 divided by x to the third because it's a cube root. I'm going to look at the table. I might start something way high. All right, that is too high. And all right, so I get 10 and 2. So 10 cube root of 2 plus square root of 2. Let's do 128 now. So I'm just going to kind of cheat a little bit here and just type it in there. I see 2 and 16. Let's make sure there's nothing else. Oh, there is. There's 4 and 2. So that's the one I want to use, is 4 cube root of 2. All right, so now I look and I notice that these are like radicals. So they have the same index, they have the same radicand. So I'm going to add or subtract the coefficients. So whatever they are, in this case it's subtract. So 10 minus 4 is 6. Cube root of 2, I keep the radical the same, plus square root of 2. That is all I can do because those are different indices, I think is the plural. But since they're different, we cannot combine them. And this is our final answer. You're welcome to try the next one on your own if you would like, but to keep the video shorter, I'm going to keep on rolling. All right, next. What happens when I want to multiply? So to multiply radicals, this is a binomial by a binomial. So I'm going to do x minus square root of 10 and x plus square root of 10. Okay, I could have those reversed, meaning that I could do it the opposite way, but for this sake it's fine. X times x is x squared. X times negative 10 is negative x square root 10. So the x is on the outside, the square root of 10 stays on the inside. This one's going to be the same thing but positive, so x square root of 10. And then for this one, I'm going to have negative times positive is negative. Square root of 10 times square root of 10 is going to be square root of 100. And notice that the square root of 100 is one of those perfect squares, so it's just negative 10. All right, clean it up. So what's really nice is if your last numbers are the same and your first numbers are the same, and the only difference is the sign in the middle, you're going to get something decently pretty. Here's what I mean by that. I have x squared. This is going to cancel because it's the positive and negative of something, so that's just 0 minus 10. So all of that work for just x squared minus 10. If you're really good at memory tricks, you just have to remember that it's the first number squared minus the last number squared. So if you want to make yourself a little note, first number squared minus second number squared. All right, last example. So why would we need to use that multiplying ever? So way back when, it was a thing that you never wanted divided, you never wanted to divide by something with a radical in it, because that's not easy to divide with. Like, it's easier to divide by a whole number. So the way that we can make that happen is multiplying something by essentially the number 1. But we just learned in the last example that if I multiply something by itself, like a binomial times a binomial, and change the sign, this fancy word's called a conjugate, that I will get a pretty number in the bottom. But what I do to the bottom, I must also do to the top to keep it even. Okay, and from there, I'm going to solve. So 4 times 1 is 4. 4 times square root of 5 is just 4 square root of 5. Remember the little cheat shortcut that I gave you there. 1 times 1 is 1 minus square root of 5 times square root of 5 is just 5. Clean that up. I get this. And that will even reduce some more. So if I take a look here, I notice that all 3 of those spots are divisible by something, and that something is 4. So if I do 4 divided by negative 4, I get negative 1. 4 divided by negative 4 is negative 1 square root of 5. I don't have to have the 1 out front. So there's my final answer to rationalizing the denominator.